The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, everybody. Sorry, I was running here to get something very quick. Welcome to the seismic review. This is the session before the last one, and this is the second quarter. For those who are taking the class with me, you have access to the on-demand class. The on-demand is the 55 hours I taught during the first quarter, and we are in the second quarter. So the second quarter, this is the schedule for the second quarter, and the 6/21st, which is today. We still have one more session, which is 6/28, the coming Sunday, and I will start the third quarter early July. I did not finish the schedule yet for the third quarter for the seismic and surveying, so I will start early July. I'm finalizing the schedule, and for those who took the class with me, they will be able to attend the third quarter. You still have access to the you still have access to the on-demand about 55 hours. You can watch the class 24/7. This is a 55 hours. The one I taught it in the first quarter. The second quarter right now we are, and the third quarter will be similar to the second quarter. The third quarter will be also free, not free, sorry, it is workshops, in series of workshops like this here, this workshop series. Let me see if I can get it back. Yeah, I believe it's here. So workshops, it's still 28 hours. This is equivalent to a course or offered by other vendors. So in addition to that, and this is why you will find in our brochure, or if we go to the website and we go to courses and go to seismic, and so these are the two books, the textbook and the 626, and this is the schedule that you see it in front of you here, but it says that it is 55 hours on demand, 24/7, plus the 28 hours for the workshop, so total about 83, and the access, obviously the on demand and so on. So this is for the second quarter. So the third quarter will be most likely similar to this, because there is no need to teach the class again from the beginning. So I came up with this after they changed the seismic and the surveying exams to a quarterly system. So I teach the class once, and after that I will make this class is available for those who are enrolled in the class, and I keep adding the workshops, or keep having the print, the workshop style, if you like to call it, in order to meet with you guys to go over the concept, over the problems, over whatever you would like me to discuss. So this is just a reminder, and I will repeat the same thing next Sunday when I go over the last class, when I cover the last class or the last workshop, if you like to call it this way. So having said that, let us, as you know, these are the two books I'm using. The textbook itself, it is 16 chapters, very thick book. It has tabs. And I came up with this book way back. Most likely, I think, before any other vendors available in the market. And after that, some people, they start to follow my style or something like that. This is up to them. But basically, this is the way I teaching the class, because I taught this class many times while I was teaching at school as a professor. So this really influenced me to write the book this way. It is a self-contained book. It does have the tables and the charts that you might need from the codes, the ASCE 7-16, IBC code, and so on. So this is a current one, and this is the 5th edition. I started way back, and this is the 5th edition. The 626, it does have all the problems, by the way, that I generated over these 30 years teaching this class for the PE and for the schools. So basically, the 626 seismic CBT problems, basically the problems available in the textbook. And I used to have a book. It's called the 300 book, 300 problems. It used to be available, and it's still available, but I didn't release it yet for some reason. Okay, and another book is called 2 Practice Exam Problems. So all the problems are here. So if you have the 626, you have the maximum number of problems available in the market, to the best of my knowledge. And I follow the style as far as the solutions for the problems. I try to follow the style that as if you are sitting in a classroom, so a classroom environment. Okay, so I don't know how many of you are taking the exam this month, this quarter, and how many of you are taking the exam next quarter. So it doesn't matter. I know because of this pandemic, so they are at one point of time they cancel all the classes and they start to reopen again. I hope that everybody got a chance to reserve your spot with the Prometric, and I hope that you will go to the exam site and you are fully prepared. And I wish the best to all of you. Okay, having said that, let us move on. And if there is any specific topic or any specific subject or any specific subtopic you want me to go over, I would be glad to do that, explain it. If not, we can start solving problems from my book, the 626. Okay, so let me, I can open the book and go over some problems and start to touch the topics related to the problem itself. For example, I just opened the book, the 626 book. If you have it with you, that's good. If not, here it is. This is on page 205, page 205. And this is problem 550. So let us read this problem and see what is next. So here is a problem. It says that an elevated storage bin supported on a special reinforced concrete moment frame is shown. The frame is located at a site with unknown soil type. Unknown soil type. This is something very important, especially with the current code. In the a previous code, the ASE 7-10, when we read this statement, unknown soil type, the code is telling us, so soil type, or they call it site class. Either one of them is acceptable, site class or the soil type. The code, they call it site class. The table in chapter 20, I will show you the table in just a minute. And whatever structure is, and this structure is supported by whatever foundation or foundations, but ultimately, okay, the load will come from the structure through the beams and columns and all these things to come to the foundation, and the foundation will transfer the load to the supporting soil. So the type of this soil is very, very important. As far as when we have a seismic event, it has the epicenter here, or the focus first, focus. So go to focus, okay? And the focus will radiate this, and we have an epicenter, which is point on the surface, as you know. The focus, okay? Sometimes we call this, by the way, hypocenter, according to chapter 4 of my book. You need to know these basic definitions. And let me double check, okay, to make sure that you are familiar with this illustration or table, figure 4.1. This is the focus or the hypocenter. This is where the focus or the hypocenter, this is a point or the center of the initial rupture causing the earthquake. This is the starting point here under OG. This is the OG, original ground. And so the soil type or the site class is very, very important, because as the seismic waves start to propagate from the focus or the hypocenter, and it will hit this structure, this soil structure interaction is very important, okay? Because it will affect the amount of the acceleration or the magnitude of the acceleration that this structure will experience during an earthquake event. And as I told you that the site class, they came up with 6 types: type A, type B, type C, type D, type E, and type F. It's called site class. Site class A or soil type A being the best, which is hard rock. When you have a structure that's supported by a hard rock, this is the best. Stable type soil, it will not magnify the acceleration of the earthquake when it started. So this is the best. F is the worst. And generally speaking, I say, when you see in the question a soil type E or F, which is the 2 worst ones, there is something hidden in the problem or something you have to pay attention to. And they provide us in the ASC 7-16 in chapter 20, there is a table 20.1, and it does have these, and this is the only table, by the way. It used to be in other codes, but they get rid of it and they put it only on one table, in one code also, which is ASE 7. So this table is available in my book. And again, I extracted it from this code. And let me show it to you because we need to be familiar with this. And this is a table I'm referring to, table 20.3-1. So, and these are the 6 types of soil. They call it site class. Here it is. Site classification. Site class classification or site classification. Soil type A, here it is, which is hard rock. This is the best. All the way it goes down to soil type F, which is the worst one. Soil type F, they are telling you C section so and so, which is this section here, 20.3-1. This is the section, the one I highlighted with yellow. Here it is. Okay, there is a continuation on the following page, by the way. Yes, here it is. Because it has 4 items. So it's called site class F. So site class F, where any, as you can see, any, it's boldface and highlighted or underlined, sorry. So soil type F will be selected if any of these exist. And he gave you 4 bullets, 1, 2, 3. And if you flip the page, you will find the number 4. Okay. All this I explained in the class. And obviously, I always, if there is any exception with any section, pay attention to the exception, because the exceptions sometimes they ask you about it. And here I provide you with a summary. So this is another exception here, that there are 3 possibilities in any given problem. They might tell you what is the site class is. Here it is. The site class will be stated in the problem statement, like whatever site class, A or B or C, whatever is. Or they might give you properties, like the shear wave velocity, and this is ASTMD. This is how they do perform this shear wave velocity, by the way, just in case if they ask you. Standard penetration test, SPT, and underrange shear strength. Underrange shear strength. These 3 tests, they are available in the table, by the way. The quantities or the limits are given here, as you can see. This is the shear wave velocity. Some numerical values are given. The standard penetration test, also they are given. And the undrained shear strength. All these types of tests, they listed here. So if you are given some of these, you could come to this table and to decide which soil type is that or site class is that. So this is number 2. Number 3, and this is something new right now. Okay, in this code, this was in the old code, but they added something new to it. That if they say nothing in the problem statement, or they may say the soil properties are not known in sufficient detail, or unknown soil. So in this case, D, soil D will be assumed unless the building official or geotechnical determines that the site class E or F most likely present. So those are the 3 scenarios. One of them exists in this problem here, which is The frame is located at a site with unknown soil type. The code is telling us what? The code is telling us, since the site class, this soil here, supporting this frame is not known, and I don't have any indication that E or F exist, so in this case, I will assume D. D. The code said that. The new change in the new code, or the addition they added in the new code, in the previous code, just only one D and that's it. They said, no, the D, we're going to classify it in our calculations for the F sub A and F sub V, as we're going to see. We have D, site class D default, which is this one here. I will assume that the D is the site class because I don't have. Or there is another D from testing. They have actual testing, and based on these properties of site class D, here it is, site class D, which is a stiff soil. Based on these properties, I determine the soil type is soil type D. So the new addition in the new code, to be conservative or to be safe, they said is not going to be the D as the default as we used to do this in the past. So the ASCE 7-16, which is a current code, it does have two Ds, as I told you. The D, we call it default, and D of testing. This is going to be part of the calculations for the F sub A and the F sub V. And we will come to this because I believe I can continue. Let me see if I have it here or I have a separate file for it. Let me see. When we calculate the F sub A and F sub V, so I generated tables for you, and if you don't have these tables, please let me know, and I will be glad to send it to you. Let me see if it is here or in the summary. Let me double check because this is the F, okay. No, I don't have it here. Let me see if I include it in the summary or I send it to you separately. I don't know why it's not here, but I will bring it when we talk about this problem. Let me see if it's in the other book. Maybe I put it. Okay, I will bring it. I send it to you, and the problem, my copy probably, I don't know if, but it's very important to include this table, two tables in fact, to calculate the SS and SD1 and SDS. Okay, I will talk about that. So because we are going to use this the site class either D default or D testing to calculate the design response spectrum, the design values, which is SD1 and SDS. These two values, the design response spectrum that will be used for the design. Okay, I will come to this. It is not required for this problem, but it's coming. Okay, so let us just I'm telling you that the moment that you read this statement, um, um, you will find that um, the soil type D and default must be recognized immediately in our calculations. Okay, we will come to this. Okay, because it's coming in the second one. Here it is. We need to calculate the SDS and the SD1. Okay, and in this case, I will double check. I will show you the two tables that you should have them. It will make it easy for you. Let me put it that way. It will be very easy for you to use these two tables, and instead of going through the whole process, which is not difficult, but as a tool that can be helping you, it will be a good idea. So let's go back again to this problem. So we know the difference between D default and D testing. And they have to tell you in the problem statement which one they are talking about. This one here, this is the D default. They gave you S and S1. Those are the mapped accelerations, the one we pick them up from maps. Okay. The maps acceleration, the SS and S1, the one I send it to you. I send you, I believe, the maps. Let me bring it here. I have it handy, I think. It was the white book, as I call it. Let me bring it here. I have tons of books around me. Forgive me just. I sent to all of you two coiled books. If you didn't receive it, let me know. And it has a white cover like this. One of them is the ATC-20, the ATC-20. So this is, I found it available for me, so I send it to you as a gift. So ATC, Applied Technologicals 20. This is one book. And the other book, it does have the chapters from the codes, the ASCE7 and IBC code, IBC 2018. So this is the second book. I have it here, but not the white cover. For some reason, this cover here is another cover. But basically, so if you go to chapter 16 of this book and you have it, If you don't, please let me know. Chapter 16. You will find there are some maps at the end of chapter 16, and this is what I explained in the class. Here it is, these maps here. These maps at the end of chapter 16 of the IBC or chapter 16 of the CBC. But these maps, as I told you that we, during the class, I said that we have the mapped S1 and SS. So if you look to the title here, this is the risk targeted maximum considered earthquake, a ground mission, so on, so on, so on, so 0.2 seconds. So this is the SS. And S for short, by the way, short. And short, they consider it as 0.2 seconds. So this is the acceleration that, or this is the map that we take the SS from here. This is the SS. Obviously, to read the map, you need two values. You need the lines of longitudes and latitudes. So you need longitudes and the latitudes. And the intersection of these two, they will put you on whatever. Obviously, it's so crowded such that you need a very large map in order to get very accurate readings, especially these contour lines are so closely spaced. And if you, the second half of the United States is here, and these are as a percentage of G. These contour lines are percentage of G. G is the gravity acceleration. So this is for the SS. Short. If you flip the page, you will find the second map, which is for 1 second. So this is S1. And this is for the S1. Obviously, we are interested on the west here. As you can see, this is the western side of the states. This is California. Obviously, to read it also from here is very, very crowded. So I don't expect that he will give you the latitude and longitude and latitude to intersect them and come up with the value based on the contour line, maybe, unless he give you a very large area of California, okay, or California map, and he asks you to do that. This is a very easy process. Also, it's not difficult at all to do that. But normally they give us the SS and S1. So the SS, but I need to know what is SS and S1. So the SS and the S1, this is a short, which is a 0.2 seconds, and the S1, which is for 1 second, the spectral response acceleration. They are given in terms of G, as you can see, 1.84 G and 0.85 G. These two G's will not be used, by the way, in the in numbers. We are not going to substitute for G to be, okay, 32.2 feet per second square or 9.81 meter per second square. No. But so if you find the S1 and SS with G and without G, both of them are acceptable, because in either case they so, and this is what we start with. We start S1 and SS, okay, and from here we can get the SD1, and from here we can get the SDS, okay. So those are the mapped acceleration, and those are the design acceleration. There is a difference between them. Design accelerations. Those are the values that will be used for design. Those are that will be given. This is the starting point. This is the starting point. Okay. So this is step number 1. I put, if you remember, I put them in step number 1, step number 2, and so on. So S1 and SS, and from here I can move to get the design values, and from the design values start to do the design to get the V, because our ultimate goal is to get how much is the base shear is for this structure, for example, V. If we are able to get this, this would be great. Okay. So going back to the problem, we didn't start the problem yet. Okay. I'm just translate into English every term because, okay, the effective seismic dead load W is given, including the maximum operating content, which is 120 kips. So I have here W is equal 120 kips. The stiffness of the supporting columns, K1 and K2, are given how many kip per inch. Consider the storage elevated bin is classified as occupancy category 1. Do you know occupancy category, OC? I have occupancy category 1 and 2 and the 3 and 4. Okay, so the OC let me change the word instead of OC. I prefer to use the RC. Can you change the word to make it risk category? They are no longer using the word occupancy category, and I will show you the table in just a minute. There are two tables. So they call it RC. So instead of occupancy category, we call it risk category. They change the name risk category. Risk category. Okay, so there are 4 risk categories. Okay, the risk category 1, and risk category 2, and risk category 3, and risk category 4. Just they change the name, but nothing changed. So risk category 4 is very, very important. We call it essential facilities. Risk category 1, those are the buildings that they are not having any human to live in. Risk category 3, they have some buildings like schools, like jails, and so on. And under risk category 2, they are saying that risk category 2, those are the risk categories that are not listed as 1 or 3 or 4. And this is given in 2 tables. There is one table from the ASCE 7, and I told don't use that. This is ASCE 7-16. I told don't use it. Use the one from the IBC 2018. And this table is given in my book in chapter 6. Let me show it to you very quick, which is the risk category. I believe I'm using the proper wording here. This is the first one. It is on page 203 of my textbook. And this is the risk category. Here it is from the ASCE 7, by the way. I said, okay, this is the risk category of buildings and the other structures, and they have risk category 1, 2, and 3, and 4. And I told you don't use it. Why? Because it's not really detailed as the second one. The second one on the back. Okay, this I like this too much. Even I added a little bit and modified some stuff. So this is the IBC 2018. In my textbook on page 204, it's called the risk category. And this is risk category 1, risk category 2, risk category 3, and this is risk category 4. the essential facility. So this is risk category RC. I call it RC. Okay, and this is RC, and this is RC, and this is RC. So if you came across the word occupancy category in my book, all of them they change for some reason. I don't know why this in this specific book the word occupancy is still there, but it's supposed to be a risk category RC. No change, nothing will really change. Okay, as far as just the naming only. And it is obviously we need to stick with the current naming because that's what I need you to be familiar with. So risk category 1, 2, 3, and 4. Risk category 4, as I told you that this is the most important one. Those are buildings and other structures designated as essential facilities. The word essential facilities, it is mentioned here, and I need you to be aware of that, essential facilities. I added some text with the boldface in both categories, risk categories 3 and 4. These boldface stuff, I explain what is a group, what is included in the group. So I need you to be aware of that. And risk category 2, they are saying building and the other structures except those listed in risk categories 1 and 3 and 4. So if it's not mentioned here or here or here, that means it is 2 by default. I need you to be aware of that, okay? Why we need to know this? For a reason. There is a table that we are going to get a value. This value is known as I sub E. What is the I sub E? If I go to the previous page, the earthquake or the seismic importance factor, I sub E. I sub E either 1 for risk category 1 and 2, or 1.25 for risk category 3, or 1.5 for risk category 4. So the reason that we need to know what risk category we are under, because they assign what is known as the importance factor, seismic importance factor, or simply importance factor, which is I sub E. I sub E is equal 1.0 for risk category 1 and risk category 2. And I sub E is equal to 1.25 for risk category 3, and I sub E is equal 1.5 for risk category 4, which the importance factor for essential facilities. And the higher the number, the higher the V, because we are going to see V is equal C sub S times W. This is one of the equations that we are going to see, or you are familiar with, that the base shear is equal C sub S, which is a seismic response coefficient, times W. W is the seismic dead load. Seismic dead load. If you look to C sub S, for example, one equation is SDS divided by R divided by I sub E. We write it that way, times W. This is for the SDS. As you can see, I sub E, it will be in the numerator. So the higher the I sub E, the higher the V. So for essential facilities, which I sub E is 1.5, this we call essential facilities. You will find that the I sub E is larger number, which will reflect on V, where because V is directly proportional to I sub E. I need you to know that the larger the I sub E, the larger the V. And I cannot determine I sub E unless I know what risk category you are talking about. Make sense? So I need you to be aware of that, okay? So if you, let me grab a question here from one of you or a comment. Please also need to add page number at the end of the book in the next section. I don't understand what. Please also need to add page numbers at end of of the book. I have no idea what's that. Mint index. Index for the 6 to 6. I have index for the seismic. I don't know. The textbook itself, it does have an index, nice index. Let me make sure that you have it. Here it is. The index is shown. So the index is shown here for the 6 to for the textbook. Very nice index, computer generated index. Okay. So this is available, unless if you mean index for the 6 to 6. Is this what you meant, my friend? Oh, you mean RC risk category does not have any page number? Risk category, you mean? Okay. So let me see if okay. But as I told you, and I'm glad. I will see what you meant, because the level of the computer generated index, because I am the one who is doing that. So in the textbook itself, it does have it is here. It is risk category, and here are the page numbers. Here it is. It is available in the textbook. I don't know what I thought that is missing from here, because sometimes the computer is generated index. I'm the one, I go over it one by one to select. So risk category is available in the textbook. It does have the location of all the risk categories where it is listed in the book, the textbook. If you are meaning or you are talking about adding an index and for the 6 to 6, I have no problem with that. But if this is what you meant, in the textbook is available, and it does have where is the risk category is. Okay. If you meant that to add an index to the problem 6 to 6, I don't have an index. I believe you don't need an index for that, and I can do it. It will take probably 3 or 4 hours for me to do it, which I can do it, and I can send it to you. I send another copy with the index. But the exam, and let me make sure that I understand your question. Okay, at least if there's anything I can enhance or improve or correct in your textbook. No, it is available in the textbook. I show it to you. Here it is in the index. Unless your book doesn't have this, I don't know. I don't know, my friend, if which edition you have. This is a 5th edition. Okay. Do you have on page 503? Check if your copy has any problem. Page 503. It does have, here it is, risk category in the index. So I really don't know what you meant by that, or if you have a copy that does not have this, please let me know. I will be glad to provide you with another copy. I don't know, my friend. I don't know what you are referring to. But let me just make a general statement. That's fine. I will be glad to send you a copy if you feel that your copy doesn't have that. But I believe that it could be a typo in the printing, or sorry, in the printing they make something, but I would be glad to say. But let me say something to you. And this is, and don't take it personal, by the way. Okay. During the study, yes, you can look to the index. But as you can see, when I explain things, I go to the proper page and show it to you. You need to prepare yourself to that level. If you don't prepare yourself to that level and you know exactly where things, the time will not really help you during the exam to solve the problems, or to solve all the problems, to or achieve certain number of score to pass. You should know exactly where is everything. In fact, some books available in the market, they don't have index at all. And the engineer, they use it and they passed, because you don't have time to go to the back of the book and look for the index. Okay, and in the index, for example, the risk category is mentioned here at more than one location. Okay, the word risk category mentioned many times. So which one you are going to pick? So in order to pass this exam, you should prepare. This is my suggestion, but it's your decision. And again, don't take it personally. You should prepare yourself such that exactly you're supposed to come to that level, or close to the level that I know exactly when I talk about the static class, I know where the static class is, which table, which chapter is that. When I talk about the risk category, RC, I know which table I should be using and where is this table in the book. Okay, when I talk about the I sub E, I should know where is the table for the I sub E. You cannot go to the index and look for the seismic importance factor and go and look for it. No, you will not find enough time to solve the problem to best. So yes, during while you are studying, yes, I agree with you 100%. You must should have a very nice index, correct index, and to help you during the study, but you should know exactly where everything. When you go to the exam, you should know exactly, okay, whatever number of books you are carrying, my book or other books, you should know exactly when I ask you, okay, here it is, like myself, here it is, static class. What is the static class? I know it is in chapter 6, and here is a table for the static class. You should be able to do this. Here it is. This is a table. But to go to the index and look for a static class, and you'll find the word static class is mentioned more than once. So in this case, you have to narrow your choices. So in this case, it's going to be very difficult to answer enough questions to achieve passing. Now, you don't have the luxury of the time to do that. You should read the problem, and you should know exactly where are the equations, even the equations. You should know where they are located, because there is not enough time to go there. This is based on my understanding to your question, my friend. But let us proceed. And as far as an index for this book, for the 626, I didn't provide an index. As I told you, I will be glad to do it. But these problems, you're supposed to solve these problems, and there is no such thing that you open on the exam, you will find a problem similar to this. So you cannot go to the index of the 626 and look for a keyword and say, oh, this keyword maybe it will fit the problem that in the actual exam. No, it doesn't work this way either. So this is just solving problems, and you have to work very fast and do it. Okay? And email me, please, if I misunderstood you or I don't get your point, and I'll be glad to correct anything. And as I told you that, okay, so the risk category, I appreciate if the word occupancy category by mistake mentioned. Okay, now after we read all this risk category 1, but I try to explain everything to remind you or bring you to speed. And right now is asking, what is the period? T. What is the period of the structure? By looking to this given structure, the given structure Do you classify it as a building structure, or it is a non-building structure, or you classify it as a component, a structural component, a structural component, or the fourth category, which is diaphragms and shear walls. So we have four categories, as you remember, that the current code, they have the structures are classified as building structures, non-building structures, structural components, let's add S here, structural components, and the other group, diaphragms and shear walls. The reason for that, you should recognize which one the problem that given to you under fall under. And even for non-building structures, the non-building structures similar to buildings and not similar to buildings. So the non-building structures, non-building structures, they are similar to buildings and not similar to buildings. You have to decide very quick this problem, which under category is that, because the equations that will be used will depend on the classification we are talking about. This is a non-building structure. Non-building structure, which is a self-supporting structure. And this is a similar to building. Why? Because it does have beams and columns, or a beam and columns. So this is a non-building structure similar to building. I know it's not related to this, but it will come here when we calculate the SDS and the SD1 and they start to calculate what is the base shear. And you are going to see this. Where is the question for this problem here? Here it is. There is the question number 555, the same problem. What is the base shear V, the design base shear V for the non, here it is. And now I start to call it non-building structure. So our ultimate goal is to get what is V. But this V, it depends on what type. Building structure, non-building structure, similar, not similar, structural component, and so on. So we need to be aware of that, okay? So let us go back again to the problem 555, 550, sorry. So the period T. You know the period T, and again, the period T, we have T and we have T sub A. This is called the approximate period. Approximate period. And this is the actual period based on the properties, which is one of them is 2 pi square root of m over k, or it is 2 pi square root M is equal W. W is equal mg, sorry. So M is equal W divided by G, so it is W divided by G times K. And we saw these equations before, either in terms of mass or in terms of the weight. And we do have a general equation. This is for a single degree of freedom system. The general equation, I will write it. Just give me, after I finish this, because this is for single degree of freedom. The approximate, there are three of them. T sub A is equal C sub T H sub n to power x, and T sub A is equal 0.1 n. And the third equation, the one it does have the C sub W. Let me just make sure that I copy this correctly. The one for the retaining, for the shear walls, masonry and concrete shear walls. And again, the moment the moment I have doubt about an equation, I know where it is located, and you should be able to do that. Here it is. This is the equation, the one C sub W. Here it is. So this is a 0.1 n, and this is T sub A. You should be able to do this. Is CQ divided by square root of C sub W H sub n. Those are the three equations to get the approximate period. And this is from the structure dynamics, which is this equation here. This equation here, this is a lengthy one, which is T is equal to pi square root of W I delta I squared divided by G times the sum of the Fi delta I, which is this equation here. This equation, the general one, T is equal to pi square root of, and always write the equations, the sum of the Wi delta I, W is a weight by the way, delta I square, divided by the G of the sum of the Fi delta I. And this is the equation for a single degree of freedom system. This is the simplified one for a single. This is for a general degree of freedom systems. This for a single degree of freedom, for one. So going back to the problem, so with the moment I read the problem, I should know which equation I'm going to use. When I read this problem here, I should know exactly which equation I'm going to use. Okay? Again, based on the type. It is non-building structure similar to building. So in this case, the problem number 550. Number 550 of the 626 book. T is equal to pi square root of W divided by G times K. This is the equation I'm going to use. This is the appropriate equation. How I know that? From my studying, I know exactly what equation should be used. I cannot use this, I cannot use this, I cannot use this. And this is for a single degree of freedom. This is the general. So I pick the right equation. You need to be ready to this degree. So N is equal to, what is that stiffness K? Stiffness K is the total stiffness K. He gave us K1 and K2. These two columns are parallel. So parallel system, I know in chapter 5 that K total or K equivalent is equal K1 plus K2 because they are parallel system. This is a spring and this is spring like this. So if this is K1 and this is K2, if I need to get the equivalent to this, it is the sum of the two. They are in parallel system. This is called a parallel system. So in this case, the K is given in the problem 550, K for each one. He said that K1 is equal K2. Even he gave you K. You can calculate K, by the way. I can show you the table that it has a K value. Okay, 5.3. So I have the two Ks. It is 2 times 5.3. So it is equal 10.6 kib per inch. So right now, I will move to the calculation part of T. So T is equal to pi square root of W. Right, let me write the equation again. So it is 2 pi square root of, what is W? W is given to be 120 kips. So 120 kips. A kib is 1,000 pounds, as you know. Divided by G. G is a gravity acceleration. G is equal 32.2 feet per second square. Or if you multiply this by 12, so this will give you 386. So 32.2, 12 times 386.4. Okay, this is inch per second square because K is in inches. So it is 386.4 inch per second square. And K, do you remember K? K is equal what? It is 10 point. Units are very important, by the way. K is equal 10.6 kib per inch. This is the K of the two columns. This column here is 5.3 kb per inch, and there is another column parallel to it is also 5. So we said that this is 5.3 and 5.3, 10.6. Now let us look to the units. Inch will cancel with inch. Kib will cancel with kib. This is S square, second square. You take it under the radical will give you second because the T, it must be in seconds. If you do this math, what you will get? Anybody can help me with that? 120, enter. 386.4 divided, 10.6 divided, take square root, 2 times, and the second by times, I got 1.075 seconds. If my math is correct, let me know. If you disagree with me, don't take me to court. Let us resolve our difference here, as I always do. So I found an answer, 1.08 seconds. Here it is. So this is my answer. Any question about that? You have only 2.7 minutes per question. Less than 3 minutes, as all of you know, because you have 55 questions and you have 2.5 hours, and you don't have, so you have to read the problem very quick, and you know exactly what he is looking for, and the equations or the tables or the charts, it should be very clear to you where they are located. Make sense? Okay, let's take a few minutes break and come back. Let's continue our discussion. And and we'll see what is next. Okay. So let's take a few minutes break. Let me wash my face and come back, and probably I will pray so I can pray for you and pray for me. And right now it's about 2:20. So 2:30 we are going to come back with open mind and open heart, get some fresh air from outside. Always I joke with you, I say fresh air, air without corona, please. Okay, we need fresh, clear air. Okay, thank you. Welcome back, everybody. These are the two tables I'm referring to. I found them in my notes, the one when I was teaching the first quarter. And if you don't have them, I will be glad. Oh, no, I emailed it to them already. I emailed it, sorry. I found them and I emailed it to all of you, those who are on the record in our address book. So if you did not get it, please let me know. These two tables, and I could add them to the book, it's not difficult at all, but probably I left them as additional tool. And we are going to see it shortly. Okay. As I said that if we know the SS, if you print it, that's fine. If not, you can look at it later on. And you know S1, which it must be given to you or extracted from the charts, the one we talked about, the maps, which I doubt that they will ask you to do that because of the accuracy and the difficulty of getting very accurate readings from these crowded maps. So the SS and S1 will be given as given in the problem 550, give you the SS and S1. Okay, so it should be given to you. These two tables, the one I'm providing here, is to get the SDS and the SD1. So this is the SDS. So this is SDS. And this is the SD1. In order to save time, so what will be given to you? What will be given to you? Will given you S1 and the site class. And the second table, it is the SS is given and the site class. Under the site class for the SDS, sorry, you'll find that we have two Ds. The default D and the D based on the testing. And this is the change they made this code or this current edition of the code, ASCE 7-16. -16. So like in our case, he said that the soil type is not sufficient is not known in sufficient detail or unknown. So I will consider the default. The 2 here is not D squared. This is a footnote here. Okay. And this is the code. And you will find that the values of the SDS for the 2Ds, they are essentially the same up to a certain level of S1, SS, 0.75. Up to 0.75, they are the same. And after that, they start to change. Because of the FA, something is called FA, the acceleration factor. Because they are saying that, here it is, use F sub A is equal 1.2. When SS is greater than 0.75. So when we are exceeding the 0.75, we start to use different value of the F sub A, different from the value listed in the table. And this is why you will find that these values start to be greater than this. You can see 1.16, this is still You see, this is 1, and I have here 1.2. So they start to be conservative here because they found that the engineers who are going to take the easiest route, the default route, without testing, they start to look to the safety, and they said that we are going to be more stringent than before, especially when the SS is exceeding the 0.75. This is something I need you to be aware of. So this table, the moment you receive it, please print it and put it. Okay, normally I recommend the 3-inch ring binder. Try to put additional materials, um, um, okay, or additional problems or anything, just to make sure that you are okay. So this is something I needed to be aware of. Any footnote I added here, this is based on the current code, and this is what I needed to be aware of. So please make sure that you receive this and print it. If you'd like to stable it to the book, I don't mind to stable it to the book, okay, as an additional tool. It will save some time for you, as we are going to see shortly. Okay, so in this book here, in the textbook, you can add it, okay, in chapter 6, and probably this is the reason that I put the table number. Probably was my intention, but for some reason I don't know why, but this is additional or extra tool. So here it is. So it should be located somewhere here. After this is page 196. Page 196, you can put it on page 196, or if you'd like to put it on the following page when we start to calculate the SD1 and the SDS, which is the 2/3, I have no problem with that. It is this way. This is page 196, 197. Okay, either one of them will you can put it and stable it put here. This will save few minutes for you, or a few seconds, probably few seconds, much better word. Okay, as we are going to see shortly. So and I will include this with my notes. So please let me know if you did not receive it through the email. I just send it to you shortly during the break. Any question about that? Okay, let's go back again to the problem 551, in order to use what I just talked about. 551, the same problem, but is asking what are the SDS and the SD1, the design parameter, given all the information. Okay, so we can get this shortcut using the two tables I just talked about them. Or we use shortcut using the tables, shortcut using the tables. If you'd like to keep this number here, table 6-617 and 18, since I gave them numbers, 17, at least you know which two tables I'm referring to, and 618. And you can say this is handout. Shortcut, or using the steps from the ASCE 7-16. The shortcut, these two tables, they follow these steps, but they combine these steps for you such that it will save some time. So if I go with the first approach, just in case if you don't have. So in this case, I do have the S1 and the SS values. SS is 1.84G. So it is a greater than the 0.75. So, and this is why here it is. You will find that it is 1.84, the one is given. It is larger than, so in this case, I have to use the F sub A of 1.2. Okay, so let us do it. And after that, I will show you the shortcut and you will see the benefit of using these two tables. So what is given? This is the problem 551 of the 626. Here it is. So what is given? We're given S1 and SS, or the SS and S1, whatever order they give it to you. So the short is given to be as 1.84G, and the S1 is given as 0.85G. And the soil type or the site class is not known as he given in the problem. The frame is located at a site of unknown soil type. Unknown. This is a key statement or key phrase here we need to pay attention to. That the soil type or the site class is not known. So in this case, the code is telling me since the site class is not known or the soil type is not known, okay, whatever statement he's using, the code is telling me, Mr. Mansour, use site class D. But this will be the default. D is not the one based on testing. So the default D, the site class D, the default is a little bit, okay, different from the previous code by making the design is conservative based on the values of the SDS, okay, or based on the value of the SDS, because the SS is greater than 0.75. So what are these steps? So I will use approach number 1 steps. So, and I outline them for you as given in the code. The ASE 7, again, chapter 6, which is, here it is, on page 195. You will find that these are the SS and the S1. They already give it to me. This step already given to me. The second step, I need to get the F sub A and F sub V. If you go to page 196, this is F sub A and F sub V. They call it the site coefficient. Because the maps they are giving for site class B, by the way. Do you remember the maps? I told you that these maps here, okay? So in order to account for different site class, so they came up with this table for the acceleration and this table for the velocity. V, so it is the value of the site coefficient, long period coefficient. This is a short. This is the acceleration, A for acceleration, which they call it short period. This is the acceleration, A for acceleration, and V for velocity. To adjust the SS and S1 by these two factors. So in order to get the F sub A and F sub V, I need the site class. So in this case, the site class D and the SS for my case is what? Let us remember the SS that's given for this problem is 1.84. Here it is. So the SS is greater than, so the F sub A is equal 1. However, there is a section of the code that should be considered. You have two footnotes here. Footnote A, this is F sub A, and the footnote A here, this is use a straight line interpolation for intermediate values of the S sub S. And the second footnote here, which is the footnote B, that we need to pay attention to also use C requirement for static class of section so and so and so. And if you go to the F sub V, you will find that this is a static class D, and this is the S1, and the S1 in our case is 0.85 G. So it's greater than this one here. So I have a value of 1.7. So I need to get the F sub A and F sub V first. So step number 1 is to get F sub A and F sub V. Step number 2, which is, I outline it here for you, which is under make an adjustment. We are calculating what is known as the SMS and the SM1. By taking the F sub A and the F sub V, the one we obtained from the previous tables, and multiplied by the SS and S1. So the SMS is equal F sub A times SS, and SM1 is F sub V times. This SMS and SM1, they are not used for anything, by the way, intermediate step. Okay. So this is step number 2. I will get the SMS and SM1. SMS is equal what? Is equal to the F sub A, the one we got from step number 1, times the given value of the SS. And SM1 is equal to F sub V times the one obtained from here times S1. So this is step number 2. Step number 3, which I put also in the book as one of the, is 2/3. We take the 2/3. So the SDS and the SD1 right now can be determined as 2/3. So it is S ds is equal 2/3 of the SMS, and SD1 is equal 2/3 of the SM1. So the SM1 already you found it, and SMS from the previous step. And those are the design values that we are looking for. So this is the answer that we are looking for, or the answers for both values, the one we are looking for. This is the 3 steps. Okay. The table that I'm providing here, which we'll use it is a shortcut. Combined all these 3 steps into this table, and you will get the SDS and the SD1 directly, including the 2/3. So it's just a matter of spreadsheet I developed, and I used it before many times in order to help you or to make the situation is faster and easier for you. Okay, so far so good. Everybody is awake. I'm glad that everybody is still awake. I know today is Sunday at almost 3 o'clock now, so and you are thinking about the stock market tomorrow. Okay, so I will go with the step number 1, F sub A and F sub V. So I got F sub A for SS of 1.84G as given here. So it is, and the site class D default D. So in this case, we are going to say that F sub A is equal 1.2. And for S1 is given as 0.85G. So the F sub V is equal 1.7. So this is the step number 1 according to this here. Step number 2, I will calculate the SMS and the SM1. So the SMS is equal what? Is equal the F sub A times SS. F sub A already 1.2 times the SS is the 1.84 G. And the SM1 is equal F sub V times S1. So in this case, it is 1.7 times the 0.84, 0.85 G. If we calculate these 2 values, this will give me, this is step number 2. And then when you receive my notes, you can look at it and see. So the 2/3 is coming as a step number 3. So 1.2 so it is 1.2, 1.84. So I got this is 2.208 G, and this is 1.7 enter 0.85 times is 1.445 G. So far so good. Step number 3 is the SDS and the SD1. SDS is equal to 2/3 of the SMS, so is equal 2/3. I got SMS to be 2.208 G, and the SD1 is equal 2/3 of the SM1 is equal 2/3 of the 1.445G. So if we do this, you will get 0.67 times, since already I have that. So this will give me 0.9682. Okay, 2/3. To enter 1.445 times 3 divided 0.69, 3.693, sorry, 33. And the other one, it is 2/3, 2.208 times, and the 3 divided, I get 1.472, G and G. And this is what we are looking for. Okay, and this what we are looking for. The two values, the SDS and the SD1. If we look to these two charts, so I have the SDS, I have SS is given to be 1.84, so it is 1.84. This is 1.85. Here it is, 1.85. And I will go with the default D, so I will get 1.48. I got here 1.472 because this is for 1.85. I don't have 1.84. So if you like to use linear interpolation, you will find that 1.8 and 1.85. So you can even use linear interpolation if you like to use that. So for 1.80, I get a value of 1.440, and 1.85, I get 1.480. I need to get 1.84, which is this value here. The one is given in the problem statement. So in this case, how much is this value? So in this case, we can use linear interpolation very easy. That 1.44 enter, 1.48 minus, and I will divide this as 0.05 divided, and I'll multiply this 0.04 times, and I will add this to 1.8, 1.80 plus, it gave me 1.832. Wait a second. Uh, 1.440. Let me do it one more time. 1.480 enter, 1.44 minus, and you divide this over 0.05 divided, and you multiply this 0.04 times, enter, and 1. I know what I did. 1.440 plus, so 1.472. I added the other one, sorry. So this is 1.472. 0.72. Here it is. It came exactly like this one here. Exactly matches. Any question about that? This is if you look to the other one, which is SD1, it is 0.9. So SD1, we need to get the S 0.85. Here it is 0.85. And the soil D, so the site class D, so it is 0.963, and it came 0.963 exactly. Here it is. So this is a value. So this is what we are talking about. So these two tables, they eliminate the need to go through this um, um, these three steps. But I need you to be familiar, just in case if he give you something strange that is not really listed here in my this table. This is a very wide range and a very good range. So in order to any question about this, is I consider this is one of the major changes that they added to this code, um, um, the current code. Okay, let us go and pick another type of problems, because we need to have varieties of problems. I just pick any problem or any topic. You are very welcome to tell me what uh, topic that you need me to. But if you are able to solve these 6 to 6 problems, 6 to 6, you're supposed to solve these problems. You solve them. Um, and understand the concept very well, I don't see any problem why you will not pass. For example, here, problem 601. I just pick a problem, 601. And normally, I don't like you to look to the solution that I provided. And if you find a typo or a mistake or an error, please let me know. Normally, in the transition of codes, sometimes we have some typos and mistakes and errors. And let me know. I will review it and correct any typo or mistake or an error. Okay, this problem here is a conceptual question. No calculations. And we need to capture these problems. As I told you, when you go to the exam, you must go with a strategy. And the strategy vary from one person to another or from one individual to another. So you are very welcome to select any strategy or pick the strategy that you feel that that you are feeling comfort with. So this problem 601 of the 6 to 6 book. What is the height limit for a special reinforced concrete moment frame to be constructed at a site assigned to seismic category F, SDCF, seismic design category? So there is a table they came up with, table 12.2-1. This is the biggest table or the largest table. I have it in my book and I send it to you also. I send you the original document. I believe all of you have it except one. I believe there is one engineer. He just joined recently. I just remember. And I will send it to you, okay, my friend, tomorrow. I will send it tomorrow. I will send you the 2 books that that I gave to everybody. So this is the original table. If you have the ASCE 7 chapter 12, this is the table 12.2-1. This is how it looks like, the table in the original doc. I do have the same table, as I told you, the table that I feel that you need them, I put them in my textbook. This table is also given in the book and is available for you. It is table 12.2-1, but I modified it to make it easy for you to read. Here it is. This is the table. It is on page 209. Can you go to page 209, please, of the textbook? This is a table 12.2-1. Any table that I took from any code, either IBC or the ASCE 7, I kept this number as is. I didn't change the number. And I give you the reference. Here it is, ASCE 7. On what page? Page 92 to 90. Page 90 to 99. So it started with page 90. Here it is, page 90. And ended, okay, at page 92. So I gave you the reference. If you'd like to go and use the original table, you are very welcome to do that. I reviewed and I did all my best. And as far as I know, or as far as to the best of my knowledge, I don't have the error or typos here. But let me know. Nobody above mistakes. But you are very welcome to use the original table, but you have to be careful because you must have a straight edge, because the table, you see, it is not divided into or have it rows and columns like to make it easy. So I did my best here to do that, and I eliminated whatever. So going back to the question that we are talking about, this question here is the special reinforced concrete moment frame. So this is a category C, because they have categories in this table. Category A, bearing wall systems. Category B, building frame systems. Category C is moment resisting frame systems. So you have to be ready to the exam such that you know which table you are talking about and what are, nobody will ask you to memorize it. But I believe if you prepare yourself very well and you know that where are the tables and which page, quick, because you need to answer at least, as I mentioned, you must go to the exam with a strategy. And as I always encourage everybody, you need to prepare yourself such that you should be able to solve at least 20 or 25. If you can make them 30 questions, will be great without opening any book. You're supposed to answer 20 minimum, 25 if you can, or 30 questions without touching any book. Those problems that they are easy conceptual questions, and you can answer them without opening any book, because the moment you touch any book, either mine or any other references you are carrying with you, you are losing time. And time is the biggest enemy, as all of you know, because of the nature of the exam, unfortunately. So you need to prepare yourself such that you should be able to solve. Okay, so he gave you a specific type of building structure, a special reinforced concrete moment for SMF. And this is seismic category F. So special reinforced concrete moment for it. Here it is. Special reinforced concrete moment frame. Entry number 5. And here are the seismic design categories. Seismic category B as in boy, C, D, E, and F. And we should know how to determine the seismic design category, by the way. And if you go all the way to the seismic category F, you will find NL, no limit. And I hope that we have no limit, and here is a no limit. And this is 3, which is answer C. This is the way that I look at it. So the 601, let us see if, yes, here it is. Normally I pick, here it is, this is the answer C. And this is the table 12.2-1. I took a portion of it, and this is under C, and this is entry number 5. And it says no limit, here it is. So I'm trying to do my best to provide you with also the reference, just in case if you would like to go back again to the original big table, you can go, at least you know the source, what source did. Make sense? Any question about that? This is the type of the question that I'm talking about, that it will take half a minute or 1 minute or something like that. And I will leave the time saving, or the time I save from these type of problems, to the bulky problem that it needs a lot of calculations, and you need to get this table, you need to get this equation, and so on. Make sense? Great. What about a problem, since we are on the same page, 602? Okay, this question here, for example, the 602, this is a conceptual question, and if you open the code, you will not find an answer in the code. No answer given in the code. There is no one section I can refer to, except that I know that the R value, the response modification coefficient, do you remember the R value, response modification coefficient? It's given in the table 12.2-1, the one we were looking to it. Here it is, the R response modification coefficient. This is the name of it. Because we know, as you know, we have 3 R's. We have R and R and R sub B. I call it the triple R. This R is in one here. This is the response modification coefficient. This is the first R. The second R we covered in chapter 5, which is the rigidity. Rigidity. We use R for rigidity also. Rigidity for shear walls. Do you remember shear walls? I will show it to you in chapter 5, shear walls. We are using R, which is R is equal 1 over delta, the rigidity of the shear wall, which is the resistance to deformation. And the R sub P, this is also response modification, but they don't call it coefficient. It's called response modification factor. Response modification factor. And we use R sub B to determine the seismic force for non-structural components. I will show you the equation shortly, but let us. So in the code, the ASCE 7, they have this column here, which you call it response modification coefficient, R, and they assign numbers 8, 7, 4.5, 3.5, 8, 5, 3, 8, name it, for all systems listed in this big table. These are values in the previous code. They used to call it R sub W, but they drop the word W. They call it R only. How they came up with these numbers? These are, by the way, these judgmental factors. There is no any mathematical derivation for that. It is a judgmental factor or factors assigned to each system based on what? Based on the ability of the structure to absorb energy. The larger the number, because V, if we remember the equation I wrote before, that V, the base shear, is equal to C sub S times W, and the equation I wrote, the SDS divided by R divided by I sub E times W. And as you can see from this equation, already I talked about this is a seismic importance factor. Do you remember the importance factor? The 1 and 1.25 and 1.5 importance factor. Or if you like to add the word seismic, I have no problem. The 1.0 and 1.25 and 1.5. Those are the three values for, this is for risk category 1 and 2, and this is for risk category 3, and this is for risk category 4, RC4. Okay, always try to write something to remind yourself with, to remind you with what is meant by this and why and where can I find this, where can I find this, where can I find this. So if you ask you, where is this equation right now? Can you go and find this equation right now? Yes. You can find it so easy. You're supposed to know where is this equation. I'm not asking you to remember the number of the equation. This is equation 12.8-1. And I'll show it to you in just a minute. And after that, we substitute for the value of C sub S. C sub S is another equation number, but I combine them together like this. As you can see here, that V is inversely proportional to 1 over R. We talked about the I sub E before. V is directly proportional to importance factor. The larger the I sub E, the larger the V. And this is why they assign 1.5 for essential facilities. 1.5 for why? They need to have these essential facilities to be open during an earthquake event, like hospitals with emergency rooms, police stations, fire departments. All these are under essential facilities. We need them to be open during an earthquake event because they provide service to the public. So they assign a higher value. Okay, so I need you to be aware. V is inversely proportional to R, the response modification coefficient, mean that the larger R, the smaller the V, because this in the denominator. So when you come to this question, and they are saying that the special reinforced concrete moment frame, they assign the highest value of R, by the way. R is 8. There is no any larger value in this table other than 8. 8 is the largest. Why they assign this number, or this large number, or the largest number, to this, to some of them? Here it is another 8. It's another 8. Those are the 8 here in this category. And 8 is the largest number, as I mentioned. Why? Because of what? Because, number one, they are more ductile than intermediate and the ordinary moment. That's correct. More ductile means that more capable of absorbing energy. Ductility, the word ductility is very, and there is something called, do you remember ductility factor or ductility ratio? Ductility ratio. For example, if I ask you, where is the ductility ratio? Where is the ductility ratio? Some people, they call it ductility factor, but ductility ratio is the most common one. Ductility ratio, it is at the beginning of the book, either this book or this book. I provide you, I believe it, I have it here in this book also, the glossary and definitions. Very important. Glossary and definitions. And if you go to ductility ratio, it is a ratio between two things. I will say D, ductility here, ductility factor or ductility ratio. It is given here, it is ductility factor or ductility ratio. And the word ductility itself is here. What is a ductility? Or what's the definition of ductility? You should be able, if they ask you, which one has the higher ductility factor or ductility ratio? So factor or ratio, whatever it is, okay, this is ductility is the ratio. This is why some books they call it ductility. So if you hear or ductility ratio, don't be upset, and it meant the same thing, ductility factor or ductility ratio. It is the ratio between two things, which is a toughness over resilience. So going back to the question, I don't like to use, so to lose the track of the, or lose the question. So going back to question 602 of the 497, you will find that, yes, it's more ductile. They absorb more energy than, for sure, yes. The more ductile the structure, the higher the energy that can be absorbed. Because if you remember the curve, the two curves I draw, let me draw it one more time. Should I use straight edge, but forgive me, I try to. So this is the x-axis is epsilon, which is delta L over L, stress over strain, and this is sigma, which is P over A. And the stress strain curve for a very ductile material like steel, straight line, go up, come like that, and here we have two areas. The area under the linear portion, which is, they call it elastic energy, which we call it resilience, by the way. Resilience. And the area under the entire stress strain curve, this is strain and this is stress, as all of you know. This is strain and this is stress. The area under the entire stress strain curve, this area here, we call it toughness or total energy or toughness. The ratio between these two, we call it the ductility factor, which is ductility factor, which is U sub T over U sub R. No, this is just ductility factor. I'm using, I believe, the one I just showed you, the definition. It is, no, just, there is no any symbol at all. So let me, so it is U sub 2 over U sub R. Here it is. Just to make sure that I equals to this. So this is T for toughness, R for resilience, by the way. R for resilience and T for toughness. Toughness is the total energy. This is called the elastic energy. So the higher the energy, the better the structure, and ductile structures will absorb more energy. So in this case, the third one, they undergo a large inelastic deformation without affecting, that's correct. All of the above, I will select all of the above. And I hope this is the one I selected. Problem 602. If I selected 602, all of the above, D, yes, here it is. I selected D as in David. Problem 602, and here we go. Making sense, okay? So this is the conceptual questions are really, really important, and we need to make sure that we understand these type of questions because they are really saving time during the exam. But I should, and if you open any book available in the market, you will not find probably the same question this way. It may be asked differently, maybe, but the concept on the exam, they will ask the same question, but in a different way or a different format, different terminology. But if you understand the concept, it does not make any difference if they ask it this way or this way or this way. Let me grab, I believe one of you is raising the hand for a long time. Sorry, unless if you are giving me an answer of this question, let me just make sure that answer is all, okay, of the above R is higher since, that's correct. So you are giving me the answer. Thank you very much. Okay, no problem, no problem. I'm glad that you are ahead of me and give me the answer. So we need to make sure that we really understand this question. So when you are first of all, don't look to my solutions at the beginning. If I were you, I will answer them. And the CBT, the USB that we send it to you, I hope that you already installed it on your computer. The USB, whatever color we send you, some of them are green, some of them are blue. The USB, okay, the one that has the 626, and the computer will generate questions for you. Please try to get benefit of it. It will give you 55 questions. I spend a lot of money on developing this program, and the programmer still working with me. If there is, he's not here physically because nobody in the office because of this COVID-19. So I'm trying to help everybody by myself. Forgive me for if I'm a little bit late and responding back to you, but I'm doing all my best because nobody is helping me. I am one-man show right now, going back again. So, but I'm doing my best to take care of this, correct this. But you do have enough material. You have the material that help thousands of engineers to pass. So please to get benefit of it. I cannot claim that they are perfect. No, there is no such thing as called perfect. Okay, but I'm claiming that I did all my best to develop very good material for you to help you, like it helped many thousands of engineers before you, and they passed. But they have to put the time. If you didn't study, um, um, you remember the statement I mentioned many times by Benjamin Franklin, uh, by failing to prepare, you are preparing to fail. And already you heard it from me 10,000 times, and forgive me for repeating this statement, but or this saying by Benjamin Franklin, by failing to prepare, you are preparing to fail. By failing to prepare, you are preparing to fail. To fail. Without the preparation, forget it. Forget it. Exams are so difficult, and the biggest enemy for you is the time during the exam. If you are not able to answer questions quickly and go with a very good strategy. You have to go with a very well defined strategy, and I'm here to help you as much as I can. Can we take another break before we continue the last session or the last section of this? Because I need to carry it all the way until 5 o'clock. So let me just take another 10 minutes break to stretch my back, stretch your back, and get some fresh air, and let us meet again. I know today's Father's Day. Somebody is telling me, uh, uh, okay. So happy Father's Day for all those of you. Somebody's just text me, happy Father's Day. Ah, that's fine. Okay. I don't know if my kids will remember that or not, but we'll see if they are going to send something to me or not. Yeah, somebody's sending a picture with his kids. Okay. So happy Father's Day for all of you who have kids, and let's meet after 10 minutes from now. Thank you very much. Okay, welcome back, everybody. Sorry for that. Another type of problems. Somebody asked me about this. The distribution of the lateral force, and I believe I have a lot of problems here related to this. Let me see if I can locate them very quick. Yeah. The distribution, it could be either given in a form of diagrams, or it could be given in form of language or conceptual question. Let me see if I can locate them quickly. If not, I will pick the other set of problems. But I remember I have a bunch of them here as far as distribution, because we need to understand how the here we go. These diagrams here. Somebody sent me a picture and he told me that, can you explain this? Can you go to problem 293, please? 293. Okay, I got more sheets here because I ran out of paper. So the distribution, as all of you know, is one of the steps that we do. The first step is to get the base shear. So this is page 6 here. So the first step, if you remember the discussion we had before, if you do have whatever structure is, so the first step is to get the base shear, V, using whatever approach, either the dynamic or ELF or the simplified. Those are the three methods that they are listed in the current code. So get V. After V, which is, I call it step number 1, we need to distribute this V among the levels. So I need to get F1 and I need to get F2. The force at each level. And this is called distribution. Distribution of the base shear. So the first step is determination of the base shear. Determination of the base shear. This is called the distribution of the base shear. So the distribution is done how? By this f sub x is equal c sub vx times v. Do you remember this equation? Where this c sub vx is called vertical distribution factor. Vertical distribution. Vertical distribution, I can't remember factor or coefficient. Vertical distribution, maybe factor. I will double check, either factor or coefficient, but a vertical distribution for sure. And this is in chapter 6. And this C sub Vx, whatever the name is, vertical distribution factor, it depends on the exponent K. Vertical distribution factor, that's correct. Okay, so the factor is the right name. So C sub Vx is equal what? Is equal Wx hx to power k divided by the sum of the wi hi to power k. These equations are given. Nobody will ask you to memorize it, but here they are. The f sub x is equal c sub vx times v. This is on the textbook on page 218. And this is the c sub vx, which they call it vertical distribution factor. Vertical distribution factor. This is the exponent k. This k, by the way, exponent related to the structure period. If the period 0.5 seconds or less, they take k is equal 1, which I put it here. This is my table generated for you here. So the equation, since the exponent k is 1, so the vertical distribution factor is given by this equation. If the period is exceeding 2.5 seconds, which is the second one here, so the k is equal to, which is parabolic distribution. And this is the equation. If the period of the structure T is greater than or equal to 2.5 seconds. If you are in between 0.5 and 2.5 seconds, so they are saying the following. You can take it as 2, as the here, or linear interpolation between 1 and 2. And this is why I put the k here. And the linear interpolation, just to remind you, here it is. This is the equation for the linear interpolation. And I gave you some example. Here it is. Saying that linear interpolation, if t is 0.8 seconds, so here it is. This is the equation, and k came to be 1.15. I put it also in the form of a graph. If 0.5 seconds or less, k is 1. 2.5 seconds or more is 2. In between is the linear interpolation as indicated by this line, straight line, and this is the equation of the straight line. I give you the equation of the straight line, which is the linear relationship, as you can see. This is called the distribution of the base shear. Distribution. After getting V, we need to do this distribution. Okay? So this is just to, and we'll solve problems. So this is, so this value of K, it depends on the T. If T is a small 0.5 second or less, K is 1. If T is 2.5 seconds or greater than 2.5 seconds, okay, so in this case, equal to or greater than, so it is 2, which is parabolic, and the distribution became non-linear. So if you look to this question right now, question 293 of the 626 book. He said that a 6-story building was analyzed using the base shear was distributed per the current code. The distribution that represent the force at each level F sub x if the structure period T less than or equal 0.5 seconds. I know for this situation K is equal 1 because T less than or equal 0.5 seconds. So K is equal 1 mean linear distribution. All these things are just by following the code. I'm not asking you to do anything other than just following the code. So which one is the distribution? This is wrong because this is uniform. This is wrong also because F is increasing as we go up, mean that this is F1 and this is F2 and this is F3, this is F4, F5 and this is F6 for the 6-story building. This is not correct. This is a cumulative, in fact. And this is a non-linear. This is a non-linear. This is the linear, where K is equal 1. So my answer is distribution number 3. And the answer is B as in boy. Agree or disagree? Again, this is a conceptual question. No calculations. But if you understand the concept and you know the distribution is based on a certain equation, and this equation has exponent K, and this is why I believe the answer for 293, let's go to 293 to see if I pick the right answer or not, or the people are helping me there, because I, 293, the answer is B as in boy. Hopefully, yeah, here it is, B as in boy. And I explain a little bit, here it is. If you flip the page, you'll find the continuation, here it is. Since the period T, the solution here it is, after I provide all this, just always that T less than, so K is equal 1 linear distribution. Here it is, bingo. So this is what is meant by that. Any question about problem 293? Now 294 is different. He changed it because since I wrote all these questions, so I remember them. The period T right now is a greater than or equal 2.5 seconds. And we know when the period starts to be higher or greater than 2.5 seconds, so the exponent K is going to be square. A square means this, nonlinear. This is K is equal to. And this is K is equal 1. That's why we selected this K is equal 1 for the previous question. And we ignore this because this is nonlinear. Now we are saying that this is a correct answer. This is not correct. This is not correct. This is not correct. This is not correct. And that's why I'm going to select the distribution. So the answer is D as in David or not. This distribution here. So this is the F1 and this is F2 because 6-story structure, 53, F3, F4, F5, and F6. Any question about this? Another conceptual question. It should be a piece of cake if we know exactly the conception. Okay, good, good. The problem, I solved it twice before. Now, before I go to this problem, since we're talking about the distribution, at least you can see the difference between these figures, by the way. If you look to problem 295 of the same book, 626 also, here he is asking also 6 story, and he gave you the period. But here is not asking for the distribution. He's asking the figure represent the distribution of the cumulative. Cumulative means the additive. Which is basically the V sub x equation. What is V sub x? V sub x is called a story shear. Because after we do the distribution to get F1, F2, F3, all the way to whatever number of levels, we are going to determine something is called V sub x, which is called the story shear. So this is, we'll call it V1, and this we'll call it V2. So V1 and V2, these we call them story shear. And the story shear is the one we use it to design the shear walls. This is to be used to design shear walls. So what is V sub x? This is another equation, by the way. V sub x, I will show it to you, which is the story shear equation. Is equal to, it is the sum of the Fi from I is equal x to n. This is a V sub x. Is not from 1. If you look to the question again one more time, he's referring to the equation 12.8-13. Let me show it to you in the book, which is this equation here. V sub x is equal the sum of the Fi. This is on page, by the way, page 221 of the textbook. If you have different page number for whatever reason, if there is a mistake in the production, copying and the production, let me know. I will be glad to send you another book because I need you to pass. So this is the equation 12.8-3. It's called the story shear. Here it is. The design story shear. Let's make it complete sentence here. So this is this design story shear. And the I started from X, not from 1. Because if you look to this, you will find that how can I get the V2 is equal to F2 only. And V1 is equal what? Is equal F1 plus F2. So we're adding. So the distribution of the story shear is going to be cumulative. Cumulative. Here it is the word cumulative. Cumulative means additive. Additive. You remember from the mass diagram, the one we covered for surveying or transportation? Cumulative means additive. So this is the force. As we go down, is increasing. For example, this, assuming if it is linear, so F1, and after that, this F1 plus, F6, and so on. So F6, and this is F5, this is F4, this is F3, this is F2, and this is F1. Obviously, they are not drawn to scale, by the way. So this is going to be Fx, F6. This is the sum of F5 and F6, all the way until here, which is the total, all the forces. So this is a cumulative. So this is C. So there is a difference between distribution at each level, either for linear or for non-linear, and this is a cumulative. C-U-M-U, C-U-M-U-L-A-T-I-V, cumulative. Makes sense? And that's why I supposed to select C for this question, and I will let you look to the solution and see if you look to question number 296 before we go to 297, which is a big one, and I need to go over this because again, I believe the previous class somebody asked me about that. But problem 296, what do you think? Okay, terminology and different design philosophies. As you know, one book among the 7 references, which I showed you about many times, the wood design of wood structures, ASD-LRFD by Dr. Breyer. This is, they call it the Bible for timber design. I taught this class for many times. Timber design is a very good class, okay? And it does have 2 chapters about seismic and so on. So if you'd like to be very good in timber design or wood design, look to this book and you will be happy with it. And as you can see here, they are putting here ASD-LRFD, allowable stress design and load and resistance factor design. So he said that wood structures are permitted to be designed using the following. Allowable stress design, ASD, service load design. By the way, The allowable stress design is the same as the service load design, the same thing, another name for it. Okay, so this service load means that dead load plus life load. We don't multiply by a factor. It's called the service load design. Can we use load and Z factor design? Yes. Can we use a conventional light frame construction? Yes. Up to certain height, we can use it. What about this working stress design? Working stress design is the same as the allowable stress design. So this name and this name and this name, they mean the same thing. These three names. Allowable stress design, ASD, service load design, or working stress design. Conventional light frame construction, I can show you the code. There is a code here for conventional light frame construction. This is the code that covers the wood structures that has been built in the past. My grandfather and your grandfather, they built them and they are happy with it. And there is no any analysis required. So they said that we can make it a code as long as you are meeting the conventional light frame construction requirements. If you meet certain dimensions, certain height, certain way. So in this case, they are saying that there is no need to do an analysis. So wood can be designed, used any of these design methods or design approaches, if you like to call it. Makes sense? Okay, and I hope that I answered this question. If you look at it on the back, you will find that probably I answered 296. I select all of the above, which is D as in doctor or David, or one engineer was joking with me, why you don't call it with dog, as D as dog? I thought that's fine. I have no problem with that. D as dog or D as doctor. So 296, if I answer D, that means that I am, of course, all of them can be used. So D is all of the above. All these design philosophies. But the naming, I understand that ASD, and it's mentioned in my books, by the way, I mentioned all these things. Working stress design or service load design, load design, all these things I needed to be familiar with. Let's come to the problem 297, which is a very good problem, and I need you to pay attention to that. This is called the %30 plus 100% philosophy. Which we call it orthogonal effect. Orthogonal effect. I don't know if the word, yeah, here it is. Orthogonal effects. Let's add S to match. What is orthogonal effects? And this is discussed at the end of chapter 6. Let me show it to you. Again, the moment that you see this word orthogonal, you should know immediately where it is. You should be prepared yourself to a degree that I know where it is, which section is that, the orthogonal effects, okay? So let us go all the way to chapter 6 before the problems. You will find the orthogonal effects. Here it is. You should be fast. Here it is. Orthogonal effects. It is on page 242. And you might say, wait a second, how I remember all these things? How I'm going to remember all these things? You will. If you practice enough, you know exactly where these things. Don't go to the index on the back to look for the word orthogonal effect. Yes, while you are studying, yes. But you should recognize the topics and the subtopics because there is no time. So this is what they meant. The 100%, 30%. 100%, 30%. The seismic code, they are saying that there are certain members and certain structures when we design it. If this is a structure like this, plan view, and this is the north arrow, and the direction of analysis is very important, and I get the V in this direction to be 80 kips in the north-south direction, and the V in the east-west direction, because the configuration of the structure is different, so V is in this direction is 60 kips. So the question is, when we design this structure, I don't know which direction the earthquake will be coming from. God will send it, I don't know, north, south, or east, west. I don't know. It could happen in this direction. It could happen in this direction. For the sake of the exam, by the way, he will specify the direction because you don't have the time or the luxury of the time to do the analysis in both directions. So the direction of the analysis is very important. I need you to pay attention. Direction of analysis. Direction of analysis or analysis direction, whatever you would like to. Analysis direction. However, the code noticed that there are certain structures and certain members. It should be designed for what is known as the orthogonal effect, which is 100% plus 30%. So we don't design for one only, we design for the 100% of the maximum plus 30% of the other direction. One of these members that they are required to be considered for the orthogonal effects or the orthogonal combination procedure is listed here on page 242, the same page, that seismic design categories D, E, and F, when he said that a column or a wall that form two or more intersecting seismic intersecting systems. So in this case, he is giving you this scenario. He is telling you there is a frame. And he is specifically talking about an intersecting member, which is this member here, or this, which is a DH. DH, this vertical column, DH, corner column, is part of this frame, and it's part of this frame. So he's asking what is the maximum uplift? Uplift. If I know V1, V1 is given what? V1 in the Y direction, let me make sure that is, yes, V1 in the Y direction. V1 is 80 kips, no, 100 kips, because there was a typo here. I believe I corrected here, hopefully. And V2 in the X direction is 80 kips. So the V2 8 kips, that means that I have 40 here and 40 here. He said 50% each. And the 100 is going to be 50 here and 50 here. So I will take two frames and calculate the uplift force here. due to this direction, and after that I will apply the 100% plus 30%. It's a very good problem. If we understand it, we will go home tonight. If we don't understand it, no home tonight. We will not go home until we make sure that we really understand it, okay? I know it's not an easy one, but we need to understand it just in case. Maybe this is a problem that will make it. So I have two frames, and this is a little bit of a structure analysis, but this is a frame in one direction, and this is 20 feet. And this is a column here is HD, and this is G, and this is C. And this one here, it does have a force. This force is 40 kips. This is one frame. Here it is. So I took this frame here. HGCD. Do you see that? Let me get it closer here to the drawing. And so I took this frame. I will color it. I know the blue is overlapping. So this is the frame that I took. The other frame, let's make a different color. Make it green, for example. This is the other frame. Here it is, which is a 40 feet span. So I will take the 40 feet and this is E, and this is H, and this is G, D, sorry, and this is A. So A, E, HD or DH, which is this column here. So this column is repeated twice. The HD, this is the blue one, and this is 40 feet, which is the green one. You see the green one. Okay. So how much is the force on the green one? Is 50 kips, which is half of the 100. 100 is going to be 50 here, 50 here. The 80 in the other direction, 40 here and 40 here. Any question about this so far? So I took two frames sharing this column, or a column that intersecting two different or two intersecting lateral force resisting system. I need to get the uplift force. So if I some moment, let's take this one here. If I some moment here for this one here, some moment here, the height here, by the way, I should get the height. The height is 24 feet. If I some moment about C here, sigma moment about C equals 0, and I will assume clockwise is positive. So I know the reaction here, which is the uplift force, I will call it F1 or U1, call it uplift 1, U1. So I will say that it is 40 kips times the 24, and this is positive, minus U1 times 20 equals 0. and I will solve for U1, the uplift force 1. So it is 40 times 24 divided by 20. So in this case, this is 2, so it's 48 kips. So I get U1 of 48 kips. So far, so good. Any question up to this stage? I will look for the second one. I need still talking about this one here, the HD. So the HD. So I will sum moment about A. Sigma moment about A equals 0. Moment is equal force time distance. So I will call this is U2, not the U2 bomber, by the way. So, and again, clockwise is positive. Some moment here. So it's still the same. It is 50 times 24, and this is negative. And the U2 plus U2 times 40 equals 0. And U2 is equal 50 times 24 over 40. This cancel, and this is 6. It gave me 30. So it's equal 30 kips. This is a U2. Any question about these two pieces of calculations before we proceed? Because if we understand this, we're almost there. We are almost there. And it seems to me there is a question or a comment or a suggestion or a correction or a criticism or all of the above. Question. 48 theory, uplift. Oh, so you are answering me, okay? Okay. Or you are ahead of the game and it's telling me that you are getting with a number. We'll see what the number you are getting, and if we are in agreement, that's good news. If not, we will correct. But so far, I saw that you got these two numbers, which is good news. So I'm just drawing and showing you this. Right now, we need to apply the orthogonality effect or orthogonal effect. Orthogonal effect. Effects. Okay. So the code is saying that we need to consider the 100% of the larger plus the 30% of the smaller. So in this case, the orthogonal effect is 100% of the larger one, which is a 48 kips, plus the 30% of the 30 kips. So in this case, 100% of the 48 is 48. 30% of this, 1/3 of 30 kips. So is 9 kips. So 9 and 8 is 7, 57 kips. So as you can see that we are going to design this intersecting column at the corner of the two systems, not for 48, not for 30, we design it for 57 higher, because it is a critical member and this is something very, very important. Again, we need to remember how to do moment. Moment is a force time distance. Never forget that. Moment is equal force time distance. It doesn't change. So, and this is why you'll find that I hope that I selected answer D in my answer, and I hope in my solution. So please let me know if you have any question. And I am working on errata, by the way, and errata for seismic and the surveying books since I changed them. So normally the first printing of the new edition, this is the new edition, the first printing. Sometimes it does have typos or mistakes or errors. Nobody above mistakes or errors. So normally I issue a print an errata. If you have any typo or mistake or an error that you found, please let me know, and I will include it in the errata and put your name next to it. So, and I will tell you thank you. So let me stop here and let me ask a question before. I'm so glad that I survived. I have the class this morning from 9 to 12. It was transportation. Yes, today was transportation. And I said that I'm going to survive the whole day, and I'm glad that I did. But okay, with your cooperation and help. And so if we are going to meet again, as I said, that we still have one more class next time. And the question I need to ask, if you are taking the exam very soon, let me know. Let me know if you are taking the exam very soon. Please let me know, and I will be glad to do something like special session for you. But I need to know what are the problems or the topics that you want me to go over it. Okay, I need you to you are going to be the one who is going to determine the topic or the topics you want me to go over, because I assume that when you are getting the exam, you are or close to the exam, that you prepared yourself very well, and you put, normally I ask as a minimum of 200 hours minimum. So minimum greater than or equal 200 hours plus the class, Don't count the class time as part of the 200 hours. No, you should put minimum at least 200 hours sitting and solving problems, and do mistakes, no problem. If we did a mistake here, this is the right time and the right place to do mistake, because our mistakes right now, we will learn from it. But the mistakes that you do in the exam, you pay the price for it. Okay, you will be penalized for it. Here, no, there is no penalty for mistake, except that we are losing a few minutes here or there, but we can make it up. Okay, but unfortunately, the mistake over there, it's extremely costly. It costs your time and money, and time is very important, because the kids nowadays, I say, Daddy, you are leaving us alone here, and today's Father's Day, we're supposed to celebrate Father's Day. So please let me know, and I will do my best to help you. Okay, when I come up with the third quarter schedule, for sure you will get it, and I will do my best to help you all the way. So try to put the hours, because so if you are taking the exam very soon, simple email. You don't have to tell me right now. I don't know how many of you are taking the exam very soon, and I will be glad to help you to set a special session for whoever will take the exam, and I will be glad to help you. You are very welcome, my friend. Try to do your best and enjoy the rest of your day. I know, happy Father's Day. I don't know, you will go now. Daddy, you came late. It's almost 5 o'clock and you are coming to celebrate. No, you still have some time to celebrate Father's Day today. Okay. Thank you very, very much. I wish you the best. Let me know. How can I help you? I need you to pass. This is what I'm really shooting for. Okay. So I will scan the stuff and I will send it to you either tonight or early in the morning, and we'll take it from there. Thank you very, very much. And this lecture is going to be available also. I ask the people who are helping me, or my staff, to load it on that YouTube, because it's a free. So I will do my best to have it ready for you. You can go to our website, and if you go to the website and you click on our home page, I believe it is, you will find it on the home page. Let me see if I can go back, and you will see, okay, so let me go the home page from here, and yes, here it is, free workshop videos. If you click on that, theoretically speaking, it's supposed to take you to the where did I click on the right one? Let me see. Here we go. So the free workshops, so surveying, civil bridge, construction, seismic, and the transportation. So here it is. So these are the sessions, by the way. Okay, so if you click on one of them, it's supposed to take you to the lecture. You can watch it again and again for free. No, I don't charge you guys. Okay, no problem. Okay, so for those who are taking the free, so these are the free. So we put them to make it available to help you guys to pass. Okay, thank you very, very much. Stay away from the COVID-19. Try to be safe as much as you can, and I will do my best. Okay. Okay, good night, everybody. Bye-bye.